Hello, and welcome to Migrating to the Cloud, part of the Thinking Cloudy series. Now, here with John Ellis, I'll let him introduce himself.
Hi, everyone. My name is John Ellis. I'm co-hosting today with Brian Nielsen. I'm a 20-year vet of the technology industry. First half of that was in software development exclusively on the Microsoft platform. Second half of that career has been in technology consulting services and training, specializing in data, business intelligence, and AI enablement. Thanks for having me, Brian.
Definitely. And I'm Brian Nielsen, Senior Cloud Training Architect at Opsagility. Been a public speaker at SharePoint Saturdays and got to participate in the Microsoft Pressbook. Also been working over 20 years in the IT industry. Worked from small shops to Fortune 1000 companies. So hope to bring a lot of knowledge and value to this. To get an idea of what we're going to cover in this, we're just going to set some ground rules. We do know that there are going to be some questions and answers. We're going to look at all the questions at the end of the presentation. So if you do have any, just put it in the chat and we'll get to those at the end. For the topics, we're going to do a quick cloud overview and have a lot of discussion around that. Then go through some reasons why you would want to move to the cloud. Why would you have any rationale, or why is your data center kind of becoming obsolete compared to migrating to the cloud? We're going to look at considerations for migration. What should you plan for? What should you look for? What kind of time frame you should look at? We're going to deep dive into AI, data, and applications. So we're going to have a lot of conversations and just a lot of scar tissue and experiences that both John and I have had for migrating these type of topics directly into the cloud. And with that, we'll go directly into the cloud overview. One of the interesting things with the cloud, I found a unique article. It was talking about pets versus cattle. And if you think about how a normal data center is, if you spin up a server, it's usually one person owns that server. It isn't a completely agnostic thing that is spun up and spun down as needed. Very, very cared for. So you treat it more like a pet than you would a cattle, where it's a mass production thing. So one of the good things about treating it a cattle mentality is it's more of a commodity hardware. You expect it to fail. With a in-house where you're treating it more like a pet, you're going to maintain it on a daily basis. You're going to apply security patches. You're going to be doing these daily maintenance things that take a lot of time out of it. If you look at what compute power brings to you with the cloud, you view it as a utility. It's just there. So you can actually achieve more value out of it rather than have to go to your data center, rack a machine, provision operating system, get all the networking set up. It's much easier to do. Johnny, got anything else on that?
Nope, right there with you on that one.
Other is going to be safety and security. If you look at the data centers that are in the cloud, you look at the number of servers and the number of machines that are available, they're in the tens of thousands. Data centers, you're at a couple thousand. You may be in millions with some of the massive data centers that are being put together right now. The security protocols that are in place are pretty much impossible to duplicate for a small data center to accomplish. The price to get into that is extremely difficult. You've got face identification, you've got security badges, you've got background checks, you've got all these different things that really put a price barrier to compete with that kind of safety and security. Also, if you look at infrastructure cost, being able to spin up a data center now is extremely expensive, from the land cost to cooling it to the electricity. All these things are getting more and more expensive, and it's really hard to compete with what you can provide with the cloud. There's a couple different types of ways that you can actually deploy to the cloud. One is going to be IaaS, where you're just basically using infrastructure as a service. So if you think of real hardware that you currently have in your data center, if you wanted to do like a lift and shift and just do one-to-one without really evaluating your migration, you look at reinstalling the workload onto this IaaS servers. And you could also use this as a failover. So if you wanted to just get an introduction into the cloud, doing a cloud failover would be a nice way just to kind of consider what the cloud's going to look like. Another good value with using the IaaS is you've got legacy hardware migration. I've done several migrations where it was a SQL Server 2000 machine, and there's zero support for it at all. So what do you do? I mean, there's not many options, especially when the hardware that's on is no longer supported, the OS is no longer supported, but you do need to keep maintaining the actual operating system for the system that you're using. Also, for a lot of these, you can do a physical to virtual migration. So if you want to virtualize your machines that are physically in your data center, you can migrate those to virtual and then take advantage of the IaaS. What kind of things have you seen, John, for migrating?
Well, one of the things I do want to bring up, you mentioned security. Now, security, being that I play mainly in the data space, I've been involved with Azure since back when it was nothing like what it is today. It was the very strange first Azure, if you remember that one. You know, Gen 1, it was a little unclear what the platform was. But as we wrapped around to like 2013-14, the modern platform developed. Now, one of the curious things I'm noticing about cloud platforms in general is one of the main resistance points that I've heard over the years is security. People are inherently distrustful of the security.
Oh, absolutely.
Oh, go ahead. I'm sorry.
I would say absolutely. Financial companies have been the worst, and now they're becoming the biggest proponents of it because they finally understand they can't do the level of security that these cloud data centers can have.
Exactly. And where I saw it the most wasn't in finance, even though there used to be strong resistance there. It was in the medical industry, anything dealing with HIPAA, just anything dealing with medical. So from the years about 2014 through the end of 17, there was just mass resistance, especially in medical. And I think the problem was that most people felt that we don't fully understand the security. You're telling me that my data is going to be residing somewhat in close proximity to other companies. You know, something felt off. But what's happened since about late 2018 and forward is it feels like the tide has completely shifted the other direction. Because one of the true benefits of the cloud is you're literally looking at military grade technology practices that are completely abstracted away from you and easy to implement. And really, if you recall some of the big incidences that used to occur with cloud, particularly Azure, there were a couple of instances where I can remember companies being breached. The two big ones that popped up on my radar, they were both related to someone checking in GitHub code publicly that contained the keys to the kingdom, literally in plain text. But yeah, I just wanted to comment that on the security piece, because that is one of the greatest benefits of migrating to the cloud, is that you don't have to hire the absolute best security experts anymore. You need cloud security experts, and we defer that intense complexity off to the provider.
Absolutely. And I mean, in addition to just a simple thing as far as just doing that IaaS, you're going to get that resiliency, you're going to get that dependability, you're going to get that scalability that would be impossible to duplicate in a small data center. Even from a power perspective, the power grids that are coming in, the number of networks coming in, and just the volume of compute power that's available is absolutely massive. I've seen videos of people walking around with shopping carts just filled with hard drives, putting them inside these data centers. I mean, you just can't compete with something like that, where if you're trying to grow and trying to store as much as possible, you'll flat out grow out of a data center really fast.
Oh, yes. And another good point along this side is if you're green-minded and you care about ecology, if you've ever worked in a data center before, the energy that the compute resources are generating it's a big bill, but it's not the biggest bill. The cooling is the biggest bill.
God, yes.
And the other services. So I do know with Microsoft, they have a vision to be either carbon neutral or negative with their data centers at some point in the not too distant future. So that is another thing that you can simply adopt by onboarding to a platform, is that you can lower your company's carbon footprint in terms of data center.
Yes, absolutely. So the next one I was going to cover was PaaS. So this is going to be platform as a service. And if you've never heard of PaaS, basically this gives you, if you want to do a migration from a true application for a web application, you can simplify the small discrete functions inside there. So one of the options is Azure Functions. And just to give you an idea of cost level, the free level, the most basic level of an Azure function has 1 million requests, 400,000 gigabytes of resources of consumption per month. I've seen it used successfully for duplicating a lot of jobs and web applications to simplify processes. Saves a tremendous amount of money. Another with the PaaS is you can scale. So one of the cool things about this is, let's say right now we're closing in on the holiday season. So now you've got on and off planned workload. If you were in a data center and you had to plan for a holiday season, if you were an e-commerce site, the hardware would have to sit there no matter what if you wanted to spin it up. With the cloud, you can say, you know what, from this date to this date, we're going to upscale 50%, 100%, 200% more than we currently are. Additionally, if you're growing fast, if you've got a platform that you're just released, but you're growing faster and faster and faster, like I mentioned with the shopping cart, your flat out will not be able to provision hardware fast enough to keep up with it. And with the PaaS back end, it automatically scales to handle all that.
Oh, absolutely. And I don't know how much experience you ever had in the retail industry with retail companies doing their own data centers. You basically had to buy the Ferrari level hardware simply for Black Friday that you would use, for a 1 or 2 week span out of the year. Very inefficient in terms of spend.
Oh, absolutely. And you've got all that sand space just sitting there, just whether it's hardware, whether it's software. I mean, everything has to be built for your peak season. I worked at a tax company that was exactly the same way. And obviously, they have one peak time a year, and same issue. They had to provision these massive data centers just for peak season. And you mentioned the efficiency, just the renewable energy. The other thing to consider is the experts that are building these data centers for Microsoft are looking at efficiency. So we're looking at 79 to 93% efficiency compared to a normal data center. And that's really something that's hard to compete with, because you're just trying to keep the lights on at a normal data center, much less focus on renewable energy, much less focus on being efficient. You just want to keep it working.
Oh, absolutely. I think you just hit on one of the points that probably on the back end drives a lot of the cost savings. So we don't really get to see what happens to the compute that we're not using. But the entire approach is different. Within a Azure data center, they're not passing along the entire cost of hardware to you because you're the only person using it at peak time. Everyone's using that same hardware, and therefore they can give you your share of that hardware considerably cheaper.
Definitely. Some other things to consider just why you would want to even consider the cloud: safety and security. I mean, the security and I'm talking about somebody physically walking into the building. Well, no matter what, a cloud data center is going to be much more secure. If you're looking at brute force, denial of service, password attempts, and you're trying to deal with that with your own network security team or your own admins, you're going to get eaten alive by hackers. But the level of support and the automation that's available in these cloud data centers is absolutely incredible. And they're constantly looking for things like this. And you can look online and see actually what's happening, and if there are any denial of service attacks. If there is a data center failure, well, they can migrate your load to another data center. And that's going to be seamless to you. But if something like that happened with a physical data center, it would actually be it would probably cause a very long downtime.
Oh, absolutely. And I do hope we get into that in terms of discussing redundancy and failover. Because I had that question presented to me by just a family friend recently asking about, cloud. Their main question was, hey, this sounds really cool, but what happens if that data center caught fire? Like, do you lose everything? What happens? How long until your company is back up? So I tried to explain geo redundancy and some of the options. So hopefully we'll get in and discuss that here after a while, because that is one of the strongest points of why to move to the cloud.
Definitely. Actually, that leads me right into the next one: reasons to move to the cloud.
So wow, that's my plan. Good transition.
So I'm going to start off with new technologies. So one of the big differences with moving to the cloud is they're constantly pushing the envelope. I don't know if you've ever tried to keep up with MSDN or any of the blog series on Azure. There's a change almost every day. if not every half a day. There's something new coming out, or there's a new patch available, or something is changing the navigation that enhances a new feature and functionality. You're just not going to do that in your regular data center. You're just trying to get your product up, and you're trying to maintain that product. So taking everything you're trying to do in your normal data center, your normal day-to-day operations, and go, okay, not only are we doing that, we're adding more functionality. So our developers, our operations, our business is enabled to do more or save more money. Another one with the new technologies is machine learning and AI. We're going to do a lot more deeper dive into that, but trying to spin up your own data center to handle machine learning AI, it is an extremely difficult process. Very complex algorithms, very complex hardware to set up and software to set up.
Yeah, we'll definitely get more into that, and I've got some thoughts around that. But I think what people don't realize about the current wave of AI in the world is we would not be experiencing this had we not started massively shifting towards the cloud 5 years ago.
Yeah.
It seems to be a side effect of the ease of obtaining the hardware, obtaining the services, and building upon the backs of incredibly smart people who are putting platforms and algorithms out there. I really don't think we would be seeing this AI revolution at all if it were not for the likes of Azure and AWS and other providers.
And it's just having that compute power on the back end, because no matter how good the software is, having massive compute power, it's almost become agnostic. You don't have to think about it anymore. But it's trying to develop locally. Like if I just wanted to build something on my laptop and test AI or something like that, where I needed GPUs or something, I'm just not going to be able to duplicate that at all.
Well, yeah, and there's so on that point, yeah, what you're describing is the abstraction of the platform and the hardware, which absolutely enables this. A point that we can get into later is that there's a lot more than that that's been abstracted. When we get into data science, we're dealing with quite high level math, and it takes a very special skill set. But what they've done is a lot of the massive intelligence of the brilliant people who are developing this stuff is abstracted away and given to you in easy to consume services. And that's one of the greatest powers of what the cloud has done for artificial intelligence and machine learning.
Definitely. So I'm going to go over some of the more reasons to move to the cloud, comparing to the local data center. Capacity planning challenges. I've worked through a couple different healthcare organizations that were planning to build a new data center. And obviously you're trying to plan 5 years out, and it's like, what is it going to look like? How much space are we going to need? How much cooling capacity are we going to need? All these things, it doesn't matter what you think here is. And what's happening in the healthcare industry is we're having aggregation. So hospitals are buying more hospitals. All of a sudden, all your capacity planning is thrown out the window because you're absorbing a brand new hospital system. Extremely difficult to plan for and almost impossible to scale and deal with. And then you've got to deal with, okay, now they've got a completely different type of hardware, software contracts, hardware contracts, air conditioning contracts, all these different pieces. If it was all in the cloud, then integration between those would be much easier. Next would be hardware obsolescence. That's happening almost on a daily basis. So whether it's going to be your CPU, whether it's memory, whether it's hard drives, something is actually going to become outdated. It's no longer supported. And moving that to the cloud, whether it's from IaaS or whether it's PaaS or software as a service, you get out of that business. You're no longer having to look at the latest, greatest hardware, purchase it, requisition it, rack it, provision it. I mean, there's so many other pieces that happen with it. You're out of that business. And with that, in the site of data center, you've got infrastructure you're dealing with, cooling, power, land, support, hardware, all the networks, and if you want to deal with failover. So now you've got a dark fiber between two different data centers that you're trying to do failover for. Additionally, with the cloud, you're going to increase IT speed. I mean, I could remember going into a client and I'm going to build something out with them. I've got test, dev, and prod environments, and I've got a dozen machines in each environment. And they're like, oh, it's going to take 6 months to spin up the machines. Like, that wasn't in the plan at all. So now that's completely gone. So your velocity to actually hit the ground running is increased dramatically because you don't have to worry about, oh, we have to requisition hardware, we have to sign the contracts, we have to do all this stuff. Point to the cloud, you're just provisioning it. It also speeds up things like just spinning up and spinning down environments because it's going to be a lot faster with the amount of hardware that's available inside the cloud. One of the considerations is the learning curve. I mean, am I going completely new? Do I have to learn a completely new, different technology? Am I completely thrown out to the wind? Are my skills useless in the cloud? I mean, what have you seen, John?
Well, so on that note, what this has got my mind, spinning on right now is, so in the data space, this is probably from around 2016 timeframe, working in the medical industry on large data sets of essentially pharmaceutical and diagnoses data, all SQL Server based. Attempting to do, we didn't really call it, it wasn't so much machine learning back then as it was more advanced statistics and trying to build models. But the problem we would run into is just processing power. So new technologies were coming on board back then, such as Apache Spark.
Yeah.
The problem, however, though, was when you take a solution for this particular problem you're having to IT, the conversation used to go something like, okay, well, what can we do to get over it? We need to build a small cluster of something called Spark. And then it was like, okay, well, what is that? Well, it's an open source project. We would need to run it on Linux. And then boom, right there, they're like, no can do.
Right.
We don't have the skill set. We are, all Microsoft administrators. We can't do that.
And they don't trust open source. We don't trust free. I'm not going to put anything free.
It was really just hey, this one piece is really platform different and we're not equipped to support it. So what are the other options? So in this particular case, it was very cool to experience this because I'd never been on a server this big. But the answer was, since we know SQL Server, since we know Microsoft, we're going to have to build a bigger server. So, I mean, we built a server that cost over $100,000. It was enormous. But that allowed doing what should have been distributed big data processing as transactional processing in SQL Server. It worked, but there was a much more efficient solution. And, nowadays in Azure, Linux is kind of in the DNA and blood of Microsoft now, which is interesting. And I really like the way that they have integrated that and run with it. So in a completely Microsoft way, I can spin up a Spark cluster. I can even do one better than that. I can spin up a Databricks cluster, which is their mega abstraction around that technology, to where I can just push buttons and essentially deploy instantly and do very complicated things quickly.
And exactly the same thing with web applications. If I'm going to spin out a web application, I'm just not provisioning a new Windows server, and then I'm going to provision IIS or FTP and all these other pieces that go along with it and apply the SSL certificate. I'm just deploying a web application. So the scope of it is much smaller now. So you're not deploying these massive pieces to it because you can point directly to it, and now you're just going directly to a web app. It makes it much easier to deal with.
Well, yeah, really, in the cloud, I mean, what is a web app really? I can think of probably a dozen different things that present themselves as web apps. So the flexibility on that back end is immense.
Absolutely. Another really cool thing with a reason to move to the cloud is billing. Because if you had just a data center and you wanted to build different departments based on utilization, normally it would be like HR has Kronos or HR has a McKesson system. I mean, just each environment would have their own system, but you really couldn't charge back for that. With the cloud, you actually have the ability to charge back and have discrete resource groups or discrete subscriptions that would allow bill back for that utilization.
Oh, very neat. Okay.
Yeah, I was looking at a particular big migration right now, and for every application that they own, every single application is going to get its own unique subscription.
Oh, that's an interesting strategy. Okay.
Yeah. So it is the world's largest Azure migration. It's happening right now.
Wow. Okay. That's an interesting use of subscriptions. I'm quite familiar with dividing out subscriptions for dev and test, and perhaps even different subdivisions of, say, a global corporation.
Sure.
You're going to split them out that way. But yeah, that's a unique approach to using subscriptions.
Yes. And basically, you kind of silo your dev, test, and prod within that subscription. So really unique concept I've never had thought of before. So let's take a look at the considerations for migration. So one of the big ones is going to be time frame. And that's usually the first question is how long is it going to take? It's like, how long is it going to take to get to this interval Tootsie Pop roll kind of thing? It has a lot of dependencies to it. I know, John, from the data side, it could be one day. It could be to the point where you need to actually bring in an entire, I can't remember what the name of the boxes, but Microsoft actually has physical boxes you can bring into your data center and copy it over and then ship that directly to an Azure data center.
Oh yeah, I haven't seen that done in quite some time as the pipes are getting fatter in terms of internet bandwidth. But yeah, I forget what that service was, and I saw that happen one day. Overnight boxes come in, you unpack them. There's USB hard drives. You start copying, and then you mail it.
Yes. Another one considerations for is whether you're going to lift and shift and migrate. So I brought up a little bit on the IaaS side. I mean, there's absolutely a desire if you have a C-level or just an organization concept that, hey, we're going to shut down this data center by this particular date. So we're just going to do a one-to-one migration. We're not going to evaluate everything we have right now, but we're going to shut down our data center. It's costing too much. AC's broken, whatever the issues are. One of the things that you can have is just do a true one-for-one. Whatever machine you have here, you're going to spin up that exact same machine in the cloud. The other way to consider that is whether you're going to start rewriting those applications little by little. And that's when you start actually getting a lot of the benefits of this, because besides the savings for the cost of hardware, software, and physical layout of your data center, the cost of running a true IaaS in the cloud, it can actually get fairly expensive. And that's one of the reasons you do want to consider rewriting things. And with that, there's a lot of tools out there like Moeva that allows you to do right-size provisioning. So they'll look at your actual data center as it's sitting right now, run a lot of processes against that, and actually analyze, here's what you're actually utilizing, here's what your cost would be if you migrate to the cloud, and this is what you should be spending that.
Okay, interesting, good.
Another one is workload compatibility. So is everything going to be able to be supported, or is it just going to happen a lot faster for this kind of workload? So I know on the data side, you mentioned the Ferrari version. Another one I heard with like Hadoop is Hadoop's basically a freight train. It takes a long time to get going, and then once it's running, it's going really fast. But again, it's hard to stop again. But that same mindset really doesn't exist in the cloud. It's just spinning up, and it's compute power. It's sitting there whenever you need it. So it's a completely different concept of how you would get things going inside your data center. But it's definitely something to consider if you're looking at migrating.
Oh, absolutely. And that's and I love the way that it is abstracted away from the user. So whenever we are deploying databases to Azure as native SQL databases, so that would be the Azure SQL database product. Mm-hmm. Right there on the control panel in the Azure portal, you have a slider. If I need more compute horsepower, I literally log in, slide it to the right, click update. It takes less than 5 minutes to provision all the backend servers that seamlessly, without interrupting any of my data access, ramp up the capabilities of the platform, and then I can turn it right back down. That's pretty impressive, at least to me, because it's a complete abstraction away of a lot of complexity, so that I can just focus on, hey, turn this dial, go faster, turn this dial again, go slower, save money.
And that was one of the kind of promises when virtualization came out. It was like, this is what you can do. It's the underlying concept is I can have a rack of 20 or 30 machines and have VMware say, oh, I'm only going to have these 10 running. Oh, if I need to have all of these running, then I possibly can. But no matter what, you're paying for all those machines to be online and ready. So they're all hot at all the time. With the cloud, you don't care. You're just, like you said, you're moving the dial and said, I want more compute power now.
Absolutely. And when we're getting charged by the minute now, it's brilliant.
Yes. So that's one of the things we should cover is how charges actually happen. And I've seen some of the services go down to the second now. So if you're spinning something up and as soon as it's shut down, that second, you're no longer getting billed for it.
Oh, that's even better.
Yes. And that definitely saves a tremendous amount of money when you're looking at migrating to the cloud. So we're going to go ahead and jump into the AI conversation.
Oh, excellent. Okay. I think I'd like to participate in this one.
So one of the amazing concepts, and you glossed over it a little bit, is the pre-built accelerators that are already here.
Oh, yeah. So in terms of that, let's kind of define some terms then. So I think at this point in time, when we're talking AI, I believe everybody understands we're talking machine learning, we're talking self-learning algorithms. We're effectively talking about the automation of what used to be called statistics.
Okay.
Somewhat. In previous years, there was some major confusion just around the terms machine learning and AI. And when we get in, we're talking about intelligence. What do we mean? Are we talking about, like, do these machines have feelings? It's
yes.
But I think we're kind of coalescing on an understanding that we're talking about somewhat intelligent self-learning algorithms, for instance. Now, what's behind all of that, obviously, is some pretty intense mathematics, a lot of heady subjects, a lot of abstract thinking that goes into it. It's hard to get your head around it. I think everybody knows that. So previously, before there were ubiquitous AI services in the cloud available, you had to roll your own for nearly everything. Now, you could do for small workloads, maybe you would hire a SaaS expert, and that particular piece of software would have built-ins that they could use. But you're not really going to productionalize, say the back-end tooling of Bing.com using something like that. You've got to have something more robust.
Sure.
So implementing complicated AI solutions before you could just buy the cloud service, it required a very specialized team, of which virtually no business had on staff. So we take, one of the greatest things I'm noticing today is I was working for it was a medical company, but on the retail side, they sold medical equipment. They had a catalog of upwards of 1 million SKUs that they sold. Mm-hmm. So there was an immense problem around trying to make sure that all of the artifacts for every listing in their catalog was accurate. So third parties similar to the way Amazon perhaps works, where third-party sellers can manage their own store. If they're doing something strange or malicious, it might take Amazon, in the early days, a few days to figure it out. But so what they needed to do was figure out if product descriptions, product prices, and the images of the products all lined up to indicate something real and not something that was attempting to commit fraud or just mistakes. You don't want to sell syringes, but you're showing pictures of, walking canes. It might confuse the purchaser. Mm-hmm. So there was this need to essentially analyze images and at least get a high level understanding of what is this thing. Is it a chair? Does it look like a syringe? Does that, look like a bandage? So we were able to use some Azure services to spin through every single image in their entire catalog and label it with something, and then put an algorithm behind that would essentially do text analytics on the descriptions and the titles of products. And when the system thought there was a big variance between what was contained in the image and what was contained in the text, we would get an alert, and then you could start a human intervention process through a web app to where somebody would look at it, flag it as good or not good, and then it would go down a workflow chain and people would attempt to fix the catalog. But the interesting thing about that is that piece of the solution we put together in the initial POC phase, and it took a couple of days. And the reason why it took a couple of days is because within Azure, you can spin up, you don't have to spin it up. It's an API. You can call it image recognition API, and for fractions of a penny, all that hard work is done for you and it's handed to you. The alternative would be if that didn't exist, they would have to hire data scientists. They would have to hire most likely deep learning experts, which are few and hard to come by. And we'd have to start the process of maybe even innovating on the algorithms themselves to figure out something that could recognize what's in these images. And then you have other immense problems, such as Well, I've got, say, 800,000 images of stuff. Is that enough to actually train a model that understands? Or do I need to sample, do I need those 800,000? And then do I need to know what, 4 million instances of other things look like for the algorithm to check it out? Now, in Azure, for that fraction of a cent, you've got a model on the back end that is most likely trained upon billions of images and labels.
Oh, God,
Yeah, the power and the efficiency of what you're getting through API-driven AI as a service is incredible. And this is one of the reasons I think that we're seeing such a it's the great awakening of AI. It's starting to, almost every company is using it somewhat. And if they're not doing it themselves, they have purchased a product in the last 2 years that is heavily using these services in the back end.
I think one of the things you mentioned was you're no longer reinventing the wheel. I'm getting feedback on your side.
Oh, how are we now?
I think it's better. Nope.
Yeah,
Getting feedback.
yeah, we had a discussion I think a couple days ago, and I brought up I like to compare AI to email in some ways. Once upon a time, email was this new amazing thing, and before you would just go do a turnkey product, maybe you would do something a little bit custom, or you would go down and say, I like the concept, but let's try this thing called Lotus Notes, which is a little different, and that still exists, by the way.
Yeah.
But nowadays, nobody even thinks twice about it. Email's built into everything. Hey, I need email for my new company. Oh, well, you just subscribe to O365, and there it is. And hey, I need this particular software to email me. Oh, look, it's built in. That's where we're heading with AI, to where it is simply a built-in feature.
And I mean, you kind of touched on the image recognition, but again, you've got document processing also. So whether you're going to parse through documents or you're going to look for certain words, or you're going to have an algorithm working in the back end. If you're working for an extremely large organization, you can monitor for keywords, or you're doing a legal search across your entire organization. You could keep monitoring for certain words or keywords that either should be mentioned or should not be mentioned, or look for frustrated people. That's one of the things that Chatbot is offering. So you can actually listen to the person that's, as they're typing, and then infer whether they're getting frustrated or not. Or you can actually, if you're doing voice, you can listen to their tone of voice and decide whether they're getting frustrated or not, and that escalate it directly from that based off the algorithm.
Yes, and that's amazing. So you brought up the document search. Let me point out something with that. There was, during that same project, working with a medical company, one other aspect of that was dealing with their contracts. So I would say at this point, most companies that rely on paper have at least digitized the paper.
Sure.
But having a petabyte of PDF files and with nothing on top of that, that doesn't help you much. I suppose you could go dig through folder structures and find something. So what they were curious with is, if we put all of our contracts in the cloud, can we use some sort of machine learning or AI to help us at least understand broadly what's in them? The original vision was much deeper in terms of, hey, show me all contracts that allow this type of partnership to be formed. That's a whole other issue, and that's very difficult to solve. But the idea would be, hey, if I put all these documents somewhere, can I figure out which ones pertain to like insurance contracts? Can I figure out easily which ones pertain to medical equipment contracts? And the really amazing thing there was, we just talked about how AI is being built into platforms and it's simply expected to be there. There's this really amazing thing in Azure called Azure Search. A little bit deceptive name. It's not a search engine for a website. It's basically a document management system. You upload all of this stuff to it. It automatically processes and gives you an immense amount of intelligence around these things.
Yeah, and it abstracts all that metadata from that. So if you've got contract names, if you've got particular formats, so you can train these document processing ones to look for specific formats. So if it looks like a purchase order or it looks like a contract, it can recognize that and automatically apply the metadata and categorize it based on that.
Absolutely, yes. And that's turnkey. In that particular product, I was just blown away. It was almost turnkey.
Yeah,
and it's a very complicated semantic to solve in terms of doing your own programming.
Yeah, and I've attempted to spin up my own several different times, and to say it takes a while is putting it mildly. One of the things that you've mentioned before is working with distributed teams on this AI.
Oh yes, yes, absolutely. Yeah, that I take that for granted now because um, so for people who don't know, the nature of data science is you've got different roles that people need to fill within that. So I work heavily with AI and with machine learning. I don't consider myself to be a data scientist, though. I don't have that mathematical educational background. I come from an engineering background. I've been a coder. I like designing and architecting solutions and building them and deploying them. But I know enough about the data science process and how to use the algorithms. I have done even solo projects that are technically data science. However, though, what happens with data science teams is you're going to end up with, let's call them pure data scientists. These may not even be programmers. However, they probably do at least know their way around R and Python. They definitely probably come from a background using SAS or something like that. But these are effectively the math people. These are the people who understand, given a data set, how do I find the actual amount of information in it, and then how do we permutate that to get new information. Now, you're also going to have people on your team that are, let's call them machine learning engineers. They know enough about it. If the data scientists give them a workload and say, hey, this seems to work best if we featureize like this, and then we apply this, 5-step multiple regression approximately with these type of hyperparameters, like they can figure out this is the direction to go for the solution. The machine learning engineers know how to convert that and program that. So what ends up happening with data science teams, a lot of times, say a company, they may or may not do this, but I noticed that you're not really going to have all these people in one conference room in one physical geographical location around the globe. You often encounter consultants in this space just due to the cost of data scientists themselves. So inevitably, we end up with distributed teams, often globally. So how do we work together? And I'm not just talking about we can fire up teams and talk about it, but it's like, how do I actually edit my code and then let you take that and edit it, maybe even in real time, and we share that.
Sure.
So fortunately, with the way that the data science world is going, is pretty much our lingua franca has kind of settled on Python. There are some specialties. R is still a big deal, but Python has kind of taken over mainly because of the deep learning community. And being that, probably the most common platform to work in is something called Jupyter Notebooks. Now, it may not have to be Jupyter. For instance, there are some Microsoft products that encapsulate notebooks in their own product. On the back end, it is some sort of a Jupyter product. But what happens is, so we're hosting this in the cloud. Our notebook environment's hosted in the cloud. Any of our developers can program straight from a web browser. So it doesn't matter where they're at around the world or anything. Just the way that the centralized spoken hub model of this particular type of cloud thing works, it is simply built in from the beginning that we have a distributed environment. If we're all in the same room on the same floor of a building, good, but we don't have to be.
Definitely. We're getting close on time, so I'm actually going to go to the data conversation. But if we get any more questions on AI, we can approach that. So
Okay.
On data, we kind of covered this a little bit, but you've got the compute power just waiting for you. And that's one of the big differences. And like you mentioned with that Ferrari concept, rather than having to buy the Ferrari at the beginning, you don't have to think about it. It's just here's an instance, and it could start the size of a Hyundai today and go to Ferrari level.
Oh, absolutely. It's not just even the hardware, though. It's platforms. Um, if you're like, say, just hardcore Microsoft SQL Server shop, and you want to try out something new, before the cloud, you actually had to figure out, okay, what kind of hardware does it run on? Okay, good. We probably have to buy that. What kind of software do we need? Okay, we need to discuss licensing on that. We don't know if it's going to work, so let's call them and see if we can get trials. That typical process, which tended to get pretty convoluted in data, because in data, once you broke away from one platform, you are typically leaving the skill set of all the developers who are working on it anyway.
Right.
The difference now is, if I go to Azure, it's I might have like a Databricks environment, and we're just doing, large scale data processing in there, populating a data lake, transforming, moving around, using that to feed data warehouses. Maybe we have some pumping into Snowflake. It could be just about anything. But then what would happen is somebody would say, hey, I'm really seeing the ability to use Databricks here to do machine learning, but I really don't know the code well. I don't know how to do Python that well in this case. Oh, look, there's another product called Azure Machine Learning Service. It has a way for me to take what happened in Databricks, completely no code, graphically design out a model. Since I don't really know what I'm doing, I don't know what model to run. Oh, look, it also has features in there that I can automatically try every single algorithm that's compatible. And then beyond that, I don't really understand the mathematics of tuning hyperparameters. Look, it actually does that too. So, it'll go out. Maybe it takes a day to run all these, but it comes back and says, hey, out of the 35 algorithms that possible, here's the one that works the best. And out of the literally infinite search space of parameters to tune it with, here's the ones that get us close.
Sure.
And it's just so easy. So yeah, I'm kind of getting back into the AI discussion. But with data, what happened when you went from Databricks over to there is you completely changed platforms. You've changed the back end. We went from effectively Databricks, Apache Spark. Then we look at the orchestration engine and machine learning. That's Apache Airflow, totally different thing you'd have to go learn on your own, but it's totally abstracted away. There's another open source framework in there that some of the GUI around the workflow is built around. And then like, hey, I got me a nice endpoint that I want to deploy and use. Okay, well, click a button on the back end without me even having to know what it is. Azure Kubernetes services pop up and start spinning out containers. The containers auto program themselves with all the dependencies. It's truly amazing. This stuff was simply not possible on-prem, mainly because of hardware resources, time limitations, and expertise on staff.
Absolutely. And I'm glad you mentioned I'm getting feedback on you again. The iterate through different platforms. One of the really cool things with Azure, and I hope everybody understands this, you're not limited to SQL Server. You've kind of lightly touched this. If you want to run Oracle, you absolutely can. You want to run MongoDB, MySQL, any of these services are completely available. It is purely compute power that you can run directly on Azure. And you're still paying for what you use.
Oh, absolutely. And so I do know, one of the big things with when companies are first switching over from on-prem SQL Server to the cloud, typically the teams get very concerned about it because things are going to change. I mean, let's be honest here. An Azure SQL database is it's a limited subset of the full enterprise edition on-prem. Now we do have like SQL managed instances, which are almost identical to the on-prem version. But people like this idea that, hey, I want to use the official serverless product. I want it to be fully managed. And then if they have an application requirement, say for MySQL or Postgres, there can be that concern of, do we have to like go make a VM and Linux and run Postgres? Right. It's like, no. Actually, you can do Azure Database for Postgres, exactly the same as SQL. You can do Azure Database MySQL, exactly the same as your SQL Server. Of course, the platforms work differently, but in terms of what you get from Microsoft in terms of managing that, scaling that, managing it, securing it, it's identical. And that extends across a lot of non-Microsoft products these days.
Very cool. Very cool. I'm going to move on to the next one just because we're getting close on time. So I'm going to do a little bit on application conversion. So you mentioned a little bit about Kubernetes. Again, it's one of these things that is exceptionally difficult to scale up on-prem just because the technologies are so new and the skill sets are very, very new. And trying to go from, not only are we going to learn it, we're going to release it to production, extremely difficult to accomplish. You've also got the ability to use Azure Functions, Logic Apps, Event Grid, API management, Internet of Things, blockchain, the ability to use Azure Media. So you can have literally your own media channel posted directly from Azure. We mentioned a little bit on AI. You can actually use the AI as part of this Azure Media and look for specific content, add closed captioning based on the words that are happening, and do that translation live on the fly. When you're rewriting applications for the cloud, you're going to get better scale. You're going to get better performance. Automation is going to instantly be there because you can provision hardware faster. You can provision instances faster. Storage is going to be dramatically cheaper. Storage in the cloud is incredibly cheap. It's pennies on the dollar compared to what it is on-prem. you're automatically going to have disaster recovery and failover. And that's one of the kind of an overarching concept of understanding what disaster recovery is on-prem versus on the cloud. But we probably need to have just one entire presentation just on disaster recovery and failure, because it's a big onion to talk about.
Oh yeah, and that one we really couldn't. We would almost have to bundle that with the containerization discussion.
Yeah. And you're allowed to use the best of breed technologies. And like we're talking with the database side, where you can use MySQL and Postgres and all these different other technologies, Azure's not limiting you anymore. You're not saying, oh, it has to be C#, it has to be this particular .NET version. If you want to run Python, you want to run Node.js, you want to run React, or you want to run .NET Core, it's completely available. And they're adding more and more functionality and more languages every single day. I just want to lightly cover what the difference was, just kind of wrap up. If you consider what you're getting with an IaaS, the pieces in orange are what you're going to be managing. So very similar to what it looks like in your data center if you're virtualized. So you're managing the OS, the middleware, the runtime, data, and application. If you move to PaaS, that limits the amount that you're actually responsible for. So you're building the applications and you're responsible for the data. You're completely agnostic to all the runtime, middleware, operating system, virtualization. You don't care about it. As soon as you move to the SaaS level, where you're just absorbing, and it's a service that's provided for you, like the artificial intelligence services, all it is just an API. You point to it and you go. Incredibly fast and incredibly powerful. We do have a couple questions. So when migrating servers, how do they store infrastructure as code? And do they have any third-party tools that generate code fast? So on the first one, there's a couple different ways that you can store infrastructure as code. You're obviously, since Microsoft bought GitHub, you can store the infrastructure as code inside GitHub. When you're provisioning, whether it's going to be virtual machines, services, or things like that, it's all going to be in ARM templates. And that's Azure Resource Management is what that stands for, but it's an ARM template. And there are additional tools like Terramark that allow you to build out even larger scale instances for that. And on next one was third-party tools that allow you to generate code faster. Definitely another presentation that I'd be willing to go into, but CLI is the one that's really allows you to scaffold out applications. So if you've got a React application that you wanted to point to, then you can actually scaffold out an entire UI. Another one is Loopback by IBM. It's an open source tool that allows you to reverse engineer a database. So you can point to your database, go through a command line interface, and it'll actually reverse engineer and generate an API and your Swagger interface instantly. And it's automatically up and running with authentication running on Node.js. So there are plenty of tools out there that allow you to generate code a lot faster. And we're almost out of time. So just on an overview, we kind of went through an overview on the cloud, look for reasons of why we're going to move to the cloud, and look through the considerations. We talked about AI and data and went through the applications. But John, if you had anything else, other than that, we're looking for if anybody has any more questions. I think we're good. So I appreciate everybody for attending. John, I thank you for the time and the conversation.